Our nation's economy relies on the system by which we move goods and ourselves throughout our land. Yet this system of highways, airways, and rail has become vastly overstretched in the past 3 decades, without the resources to meet growing demands. Here we see in the background an experience common to many of our lives. It is the American traffic jam. Air and rail are likewise sufficient, so it is now time to let the highway of the future take its needful role. The time has come for MagLev. According to Jay Vranick and EPRI's Phil Simons, 2 of the most important modes are at their breaking point. On road and at the airport, the daily volumes of traffic are nearing capacity. The common solution has been to build more highways and airports, causing overdevelopment, even higher traffic, and lack of access to these same facilities. This began when the U.S. government wanted a fast form of national travel, both to support our booming post-war economy and for defense during the Cold War. It poured billions into air and highway, the fastest modes at the time. Rail was neglected. As both systems expanded, demand rose faster, and flights now take 20 minutes longer than in the 80s. Each new road mile grows more expensive to build, but provides less capacity. Meanwhile, the auto boom has driven Americans to the suburbs, leading to rundown of our downtown areas and suburban sprawl. We need a system as expansive as the highways and airways, but without the heavy costs.
Here in Germany, engineers are testing an experimental train that all but eliminates track friction. Because the train doesn't ride on tracks. This train literally floats on a magnetic field. It's called MagLev, for magnetic levitation. MagLev trains work like this. When the system is first powered on, a powerful electromagnetic field lifts the train up about an inch off the track. Powerful generators in the track then begin to produce waves of magnetic energy, which propel the train forward. Because the train never makes physical contact with the guideway, there's no friction. And that makes the train very fast. The current model is designed to go as fast as 310 miles per hour, but the technology can potentially go much faster.
The U.S. has to catch up to Europe and Japan, whose MagLev age is 30 years. By learning from their planning, we may note several aspects of implementation. Stations should be spaced 7 to 15 miles apart, and lines be routed through communities suffering from urban sprawl and suburban sprawl as well. In the city, offline track and stations should be provided to allow through trains to continue at top speed. This will give commuters better access to the center city and beyond. EPRI's Phil Simons says the costs of construction are comparable to those of new highways. 10% grades and sharp curves taken at 250 miles per hour, along with eco-friendly construction, will make MagLev easier to design, build, and implement, and easier on the environment. As a result of MagLev, travel costs will be lowered because airline manufacturing can be employed to build the track at a cost cheaper than for what rail is constructed today. The non-contact mechanism eases design parameters and removes friction. Mobility will be increased since highways and air will better interface with each other, and multi-airport cities, like Chicago, can create one MagLev-connected airport, like O'Hare Midway, say. According to MH Khan, vacationers can cut travel times by 1/3, while Boston business partners can be at New York meetings in only 2 hours, and trucking can be integrated with the speed of MagLev rather than competing against it. Fast and efficient travel will spur business development and improve the standard of living of both commuter and city dweller, and reduce unhealthy stress. This will cause revitalization of downtown suburbs that grew up around old rail lines, and do similar for city downtowns that have lost commuter appeal. Finally, mountain communities, oft poverty-stricken, will have access to rapid transit, since MagLev's design is the best possible form of transit to implement in rugged terrain. Of special interest is H.L. Song's modular city. He proposes hexagonal urban units, where people work, live, and play, that can grow like a honeycomb. This beehive concept engenders more efficient land use and is bounded by a personal form of MagLev known as Advanced Vehicle Control Systems. These maglev highways, or magways, act as sidewalks, but with freeway traffic patterns. Both urban and transit forms ensure the most efficient travel in between units. As seen on the next slide, these maglev highways, or magways, connect with each other through interchanges like our highway counterparts, but without the traffic jam. When we one day begin to implement maglev, we will experience a sustainable mode of travel, one that blends with the countryside rather than disturbing it. According to T. Moore, grazing cattle don't bat an eye as a trans-rapid maglev glides overhead in Germany. It is also more comfortable for the rider and requires less power per unit speed. Perhaps the most unseen, yet the most impacting effect, is its complete and efficient use of our AC power grid. Modern trains use only 1/3 of it. If we are to find respite from the traffic and airport lines of our daily lives, we must turn to maglev to provide a cost-effective, comfortable, and sustainable form of travel.